All right. Hey, kids, welcome back. Everybody say hi. We got Celeste and Marcus with us. All right. And today we're going to be covering angles, so I'm excited. Um, okay, now these are tools for geometry, and so we're going to be talking about measuring angles. All right, good. So with that, Celeste, what is an angle?
An angle.
Yeah. Remember, most people have a hard time with this. Remember when I said go ahead and put your hands together? For everybody at home, go ahead and put your hands together. Okay, open them a little bit, right? Give that a number. Okay. Now, and then I open them up a little bit more. Give that a number. So, I would say that this is 60 for me, and then open them up as much as you can. This, so I would say, would be like 130, right? But notice how, now do it with your fingers. Grab your fingers, put them together. Now separate them a little bit. Give it a number. So, I give this 40, and then now do as much as you can. And I would say that to me, this is well, I don't know, maybe 50. Okay. But notice that it's the distance in between. So as you open up your hands or you open up your fingers, right? Now, did the size of the hands matter? Or the
No.
fingers? No, right?
No.
So it doesn't matter. What matters is the distance in between the two sides. Okay.
Yeah.
So Marcus, go ahead and read this.
An angle is a figure formed by two rays or sides with the same endpoint called the vertex. You can name an angle several ways: by its vertex point, by a point on each ray, and the vertex, or by a number.
Yeah, so we're going to discover that angle B, you can name it angle B, or you can name it angle ABC, because you got 3 points on here. And you could go opposite in the 3 points, or you can name it by its number. Now, the thing that's very important here is that on the middle ones, notice how I highlighted the B's, that the vertex does stay in the middle, be named by the 3 points. So you can't put it at the front or at the end. Okay, so Celeste, go ahead and give me 3 different ways to name this angle.
Angle AOB.
Okay.
Angle BOA.
Okay.
And angle O.
Excellent. Yeah, so those are 3 different ways. All right, now Marcus, read this one.
The measure of an angle is the absolute value of the difference of real numbers paired with the sides of an angle.
Yeah, so, and remember how you're telling me why absolute value?
Because absolute value is always positive, and when we talk about distance, it always has to be positive.
Yeah, so that's the reason why. Good. All right, now let's go ahead and talk about, Celeste, you see how this one talks about the different type of angles? Okay, so I come to realize that most of you know what is acute, which means less than 90, right? Obtuse, which means between 90 and 180. And right, which is exactly 90 degrees. But the one that sometimes I see people do not understand is the straight angle. Straight angle is 180 degrees, and that's because you have a straight line, right? Good. All right, so Marcus, go ahead and tell me which is acute.
The top right one.
Good. Oops, I changed my pen type. Top right one. Okay. So I said, which one is the right angle?
The bottom left.
Yeah, and then you see this little right thing. So that's probably the reason why. And then Marcus, which is the obtuse?
The top left.
Yeah, sign this one. And Celeste, which one's a straight angle?
The bottom right.
Good. Yeah, because that's exactly 180 degrees. All right, good. Now let's go ahead and you notice how these are the actual definitions. So when you're viewing at home, I would like for you to go ahead and write these down. Celeste, why don't you go ahead and read them out?
Types of angles. Acute angle measures greater than 0 degrees and less than 90 degrees. Right angle measures 90 degrees. Obtuse angle measures greater than 90 degrees and less than 180 degrees. Straight angle formed by two opposite rays and measures 180 degrees.
Yes. Okay, good. Now let's do this one. Marcus, read this.
Congruent angles are angles that have the same measure. In the diagram, measure angle ABC equals measure of angle DEF, so you could write measure of angle ABC is congruent to angle DEF. This is read as angle ABC is congruent to angle DEF.
Arc marks are used to show that the two angles are congruent. All right. So a couple of things. Marcus, what does the M stand for on here?
M stands for measure.
Yeah. So when you read it, you'll say the measure. And so if I said that this is 40 degrees, and this is 40 degrees, I would say that 40 is equal to 40. But I wouldn't say that the angles are equal, correct? I would say that they're congruent, just like what we see here. All right, so now, Celeste, read this.
The set of all points between sides of the angle is the interior of an angle. The exterior of an angle is the set of all points outside the angle.
Yeah, so in this case, this is interior, the inside, right? And then you also have the exterior, which is the outside. Okay, good. Let's go to the next one. Okay, Marcus, why don't you go ahead and read this?
If point B is the interior of angle OAC, then the measure of AOB equals the measure of BOC, which is equal to the measure of AOC.
Okay, so what is this saying?
Measure of AOB plus measure of AOC equals the whole thing.
Yeah, so in physical terms, like if I say that's 20 degrees,
Mm-hmm.
and I say that this is 30 degrees, then I could guarantee that they're all equal to 50 degrees. That the two angles added together equals the sum of the whole thing. That's really what it's saying, right? So, okay. Now, this one, you see this picture here? You can name this different ways, right? So like I can name it angle 1, angle 2, I can name it angle QTR, and also I can name it angle RTQ. And the same thing here, I can name this one angle RTS. Now, can I name it angle T? No. Right? Because you see how it refers to several things? All right.
Yeah.
And then here's all the answers to that example. Okay, now let's do the next one. This postulate is just saying that everything's unique. We're not going to go over it. And now when you're using a protractor, okay, you're going to come to discover that sometimes it's important that, like, you know how this measures. So, but the thing that's important, so you see how it says measure of angle, like, let's go ahead and focus on this one. Actually, let me change this to yellow. BOA. Okay.
Mm-hmm.
What's important that you keep in mind is that you follow, like if you only use one set of measure, like I could get 40 degrees by going from 0 to 40, which is the easiest. But I could get the same result if I went from 140 to 180, right? The subtracting both will give me the 40, correct? But you have to use one of the two. You cannot use both. Okay. And I would say for simplicity, always use the one that starts with 0 because it's just easier for you to use. Okay. But let's go ahead and share the same concept with these other ones. So when we talk about DOB, okay, one thing I'll be able to guarantee you is that this is 15 degrees, and this one over here is 140. But notice on this one, you notice how I'm using the outside numbers? Okay.
Mm-hmm.
So once you do this, if you do 140 degrees minus 15 degrees, you get 125 degrees as a result. All right?
Oh.
So that's one way to do it. And then you do the same thing with this one right here.
Daddy, I need to go.
Okay, no, that's fine. Okay, say bye to everybody.
Bye.
Okay, now the last one will just be this one. BOC. And that's 90 degrees. Same thing, you would subtract and get the same value. All right. So Marcus, go ahead and work out this answer for me. Or read the question.
The measure of DEG equals 115.
Yeah.
And the measure of DEF equals 48. Find the measure of FEG.
Yeah. So this is 115 degrees, basically the outside, right?
Mhm.
DEF is 48. And then this is the unknown. So what do I do to solve this?
You subtract 48 from 115.
And we'll come to discover that 67 degrees. Okay, so this means that this is 67 degrees. All right, good. Now, Marcus, go ahead, and it gives you here an algebraically. So if you wanted to review this video and pause it, you go ahead and write this out algebraically. All right, so Marcus, which one would you use in this case right here, this equation?
How do you see?
Yes, but why?
Because it says that measure XWZ is 121, and
Yeah.
C has 121. Then it also says XWY is 4x plus 6, and YWZ is 6x minus 5.
Yeah, so the reason why you're able to use it is because of that the angle addition postulate. That if you add these together, they're going to equal to 121, which is what this one is saying.
Yeah.
Yes, everybody? All right, good. Now let's go ahead and do the next one. And this gives you algebraically how they do it, and then even solve it for you. Okay, so go ahead and all they did is combine like terms. So you see 4x and 6x is 10x, and the 6 and negative 5 is a 1. And then afterwards, once they solve for x, they went actually got the values. Okay, all right, good. Let's do the next one. All right, Marcus, why don't you go ahead and read this one out and tell me what to write down.
Write down the equation you would use to solve for x. Angle JKM is equal to, is congruent to angle MKL. The measure of JKM equals 4x plus 6, and the measure of MKL equals 7x minus 12. Find the measure of JKM.
All right, so what would I do here, Marcus?
Well, since they're congruent to each other, you could just put 4x plus 6 equals 7x minus 12.
Yeah, good. And then I just solve, right? So always take out the smaller x to move. Afterwards, I'll get that this is 3x minus 12. And then I'll put all numbers on one side, x is on the other. So then I'll get the result that 18 is equal to 3x. And then I'll divide by 3 to both sides. And I'll get the result that x is equal to 6. Now, once I know that x is equal to 6, I do need to substitute it back in. So I'll make this in red. I'll do 4 times 6 plus 6. And this is how I get that that's 30 degrees as a result. Okay, good. All right, so let's go ahead and then move on. Now, remember, I still did PIMDOS backwards. So if you're still learning how to solve, just keep that in mind. Because notice how I went ahead and subtracted here, added here. Notice that? And then afterwards, I moved to division. There. All right, good. Let's do the next one. And this one gives you like step by step as well how to do it. So if you have a chance and you're not or need to go back, in my Google Classroom, you'll see this video. Make sure you go back and copy all this down so when you upload the video notes, you already have an idea how to do it. And I would challenge you, if you're having a hard time, like if you don't know how to solve, to try to do it without watching the video. Rewrite it in somewhere separate, retry it again, see if you can actually get it this time. If you can do it on your own, then you know you got it. All right, so now let's go ahead. So Marcus, go ahead and read this question and answer for me.
Do we have enough information to solve this problem? Yes or no?
Yeah, so
I would say yes, because we have angles of TQS, angle SQR, and angle TQR because it's a straight angle, so it's 180.
Yes, you're absolutely right. So this is 180 degrees, right? Good. And then it shows you here the setup. You add them together, and it's going to equal 180 degrees. And then you just go through the process of solving it. All right, let's do the next one. Let's see. So they want you to name the angles, but here's a question: can you name it angle A?
No,
Why?
because angle A could mean two different angles.
Yes, that's absolutely right. It could be two. It could be or three,
Oh yeah.
right?
Mm-hmm.
Or three. So that's the reason why. Okay, Marcus, go ahead and read this.
An angle bisector is a ray that divides an angle into two congruent angles.
Yeah, so very easily, let's say that this is a bisector. Numerical terms, I could guarantee you that they're both the same. That's what an angle bisector, just like a segment bisector cuts something into two equal parts. The benefit that we have now is that now it cuts angles into two equal parts. So I can guarantee you that they're going to be equal, and that's important for us. And the reason why is this. Marcus, go ahead and, like this one. You see how this one talks about that it bisects the angles?
Yeah.
But this one gives us equations. Notice how it gave us this one and this one. Let me relate it back to the graph so you get a better idea of what this looks like. Let me go ahead and change these out. And then go back here. One of them is negative 10x plus 3. So that means that this is, hold on a second. Undo. 10x plus 3. And in this case, in the other one, is negative x plus 21. So all that we have, that if it's an angle bisector, the biggest benefit I receive is that now I could write down the result that 10x plus 3 equals negative x plus 21, and now I could go ahead and have the benefit of finding out the solution. So if I was going to find out the solution using this, I take the smaller x, and this is kind of weird. The smaller x is this one. It's not weird, but it looks a little weird. So once you do that, you'll get the result that 3 equals 9x plus 21. And then we make sure we move numbers all on one side. And then that gives me negative 18 is equal to 9x. So in this case, it's not uncommon that x's are sometimes negative, but what's going to happen is that your distance is going to be positive. So once you put them inside, you actually should get positive numbers. Actually, it doesn't do it on this one, but it just gives you an example. All right, now let's go ahead and see what else there is. Oh, it shows you how they do it, how they sum it and everything on this one. That's pretty much it. All right, guys. Hey, thank you so much for joining me. Rewatch this video so you can write down the notes well, and especially pause in areas that you have to. But apart from that, okay, let's go ahead and say bye. Bye, everybody. Thank you for being with us.